Analyzers. I want to do some review with you before your Chapter 6 exam in Google Forms, so here we go. All right, first things first, all of the formulas we learned in Chapter 6. Chapter 6 was huge. There was so much going on. There were a lot of formulas that we talked about, or a lot of forms of our equations that we talked about. So here we go. Standard form of our quadratic equation is y equals ax squared plus bx plus c, right? We've got the x and the y. That's our quadratic function. And vertex form is y equals a times x minus h in parentheses squared plus k, where hk is your vertex, or x equals h is your vertex, or excuse me, is your axis of symmetry. So remember, if you are dealing with this form, you do not need this axis of symmetry formula right here. The axis of symmetry formula goes with the standard form version, and that's why it's got a B in it, versus this, if you want the axis of symmetry, it's just x equals h. So opposite sign of what's inside the parentheses. Vertex is opposite sign of the h, correct sign of the k. So depending on your form, that's where you get that from. Notice the discriminant does come from standard form as well. So this is just the stuff under the radical in your quadratic formula. And that tells me the number and type of roots that my quadratic will provide me. You know, it's two rational, two imaginary, two irrational, or one real, which really is just the vertex, right, being touched. So that's where we use the discriminant. And then, of course, your sum of the roots, I usually just say sum is the negative b over a, or product is the c over a. Those are standard form as well. So these things all go with standard form, okay? And again, between the axis of symmetry formula and the discriminant put under a radical, that's how you merge them to get the quadratic function that, of course, we'll need when we have to solve our quadratic equations. So that's the thing about Chapter 6, is that when you go to take your test, there's basically 3 sections. There's the first section where you're solving quadratic equations. That was lessons 1 through 5, which were all review of stuff you did in Algebra 1, and some of it stuff I did at the beginning of the year. Then you had the whole new section. The middle section was all about parabolas. How do you equate the parabola's properties, like the axis of symmetry and the vertex and the y-intercept and any roots, to the actual equation? Okay, and that was using the discriminant, using the axis of symmetry formula, using vertex form. That was sum and product of the roots. And then the last section of Chapter 6 that we talked about just now had been systems of equations, either putting 2 functions on a graph and looking at how many intersection points they had from the graph, or doing it algebraically. So algebraically setting the 2 functions equal to each other and solving for x, then taking those values and plugging them back in to get matching y's, so you got all your intersection points. What we're going to do is we'll have each of those pieces on the test just one time. So basically, there'll be one question for every lesson from Chapter 6, because even that is like an hour and a half test. It's a lengthy test. Okay, it takes some time to get through all the stuff of Chapter 6, but all of it is so important for understanding what quadratic equations are really telling us and how they work, and how that algebra all connects to the graph and vice versa. Well, if I'm going to do one question from each section, right, from each lesson, what I'll do here is I'll basically do one question in each of the sections and let you practice on the remaining question. Okay, because I do always put more in the review, plus there were 2 reviews that you could do. I'm, of course, in exam review number 2 right now. Both answer keys are provided, so don't worry about that part. Do what you can as far as reviewing goes, what's going to help you prep for this test. And at least one of these each will help you prep for the test, okay? So find the axis of symmetry and turning point using the axis of symmetry formula. That means I need standard form, which of course I have. So I'm going to do question 1. I have standard form. I plug into x equals negative b over 2a. So the negative of negative 6 over 2 times negative 3 gives me 6 over negative 6, which of course is negative 1. So my axis of symmetry is x equals negative 1. Remember that your axis of symmetry is a line, and it's always an x equals line because it's always straight up and down, or vertical, as we say. So you always have to have it as an equation. Turning point. So just take that x value you just found, sub it back in so you can find the matching y. So you sub it back in for x, and I just keep this simple and do it on my graphing calculator. I really don't need to go any further with that, right? So negative 3 times negative 1 in parentheses squared minus 6 times negative 1, and we get 3. So that means our y value, our matching y value is 3 for the x value of negative 1. I also know that this vertex is a maximum point. And the reason I know this is a maximum point is because the negative in front here, is telling me that this is a frowny face parabola, which means that this particular parabola has a top, or a max. So I just added that detail right now, but I want that there just in case I need that for the future. Because if you look at the next section, I actually use that again. I need to find the vertex form of this quadratic function. So I need to take it from standard form and put it into vertex form, which means that as I do that, I'm going to have to complete the square to do that. So let's complete the square here. The first thing I need to do in order to complete the square is I need to divide everything by negative 3 to start. The reason being, you can't have a number in front of the x squared while you complete the square. It's got to be a 1 in front of the x squared. I know that feels like there's a complication over here with the y, but truly just leave it as y over negative 3 and don't worry about it otherwise. Okay, negative 6 divided by negative 3 is a positive 2x here. Now just put plus blank on both sides of the equal sign. Okay, the blank gets filled in by taking the middle term, dividing it by 2, and squaring it. So 2 divided by 2 is 1, 1 squared is 1. That goes here. Now, the whole point was this is now a perfect square trinomial. So that perfect square trinomial factors to become 1 binomial squared. This was the whole idea of doing this. So that 1 binomial is x plus 1. Now, all you have to do is bring this other junk that's been sitting on the other side of the equal sign back over to be with the binomial squared. Once you've gotten the binomial squared, it doesn't change. Okay, just the stuff around it does. So now start by subtracting 1 over, and you really just put that 1 at the end. Remember, this is a negative 3 that's underneath y. So you've got x plus 1 in parentheses squared minus 1 at the end. And now you've got this negative 3 here that needs to be re-multiplied into the other side. So we just re-multiply by negative 3 so that now your y is all by itself. And I will write that here. Right? And that means now multiply this entire side by the negative 3. So it just goes in front of the binomial squared. The binomial squared itself does not change. And then negative 3 times negative 1 at the end here is a positive 3 at the end. Now, the whole point of getting this vertex form was, does my axis of symmetry and turning point from above match? And let's find out. When you have vertex form of a quadratic equation, it's the opposite sign of what's inside the parentheses gives me my axis of symmetry number for my equation. So x equals negative 1. And look, that was the case above. Now for the turning point, the actual vertex from vertex form, opposite sign of in here, correct sign of out here. And look at that, negative 1, positive 3, which is what we got here. Again, I know it's a max because this -3 out front tells me this is a frowny face parabola. So this is still a max, okay, because that A value is still exactly the same. All right, so I just want to point that out. That A value stays, okay? It's the H and the K that are different from the B and the C. So that's what we want to be a little bit mindful of, okay? I do that on your test too, where there's, one question used multiple times, or excuse me, one equation used multiple times. So just kind of be on the lookout. I'll ask you for that there too. All right, here. Find the discriminant of the following quadratic equations and describe the type of roots they will have. Well, you want ax squared plus bx plus c equals 0 or equals y form so that you can find the a and the b and the c. So the first thing I want to do here is subtract this 12 over so that I have standard form. And this is of an equation and not a function because there's only one variable involved, and that one variable involved is x. Okay, so that's the first piece. The second piece is now that I know my a, my b, and my c, my a is 1, my b is 2, my c is -12, I plug those into b squared minus 4ac, or the stuff that's under the radical in your quadratic formula. So I'm just replacing each of these. And the thing is, it says find the discriminant. That's a value. That's an actual number. I can get that by plugging in right here. So let's see. We've got 2 squared minus, oh, hey, oh, hey, you, minus 4 times 1, which we know is 4, times -12. And that gives me 52. Okay, so my discriminant value is 52. Now what I do is I think about what is 52. 52 is a positive non-perfect square. So it's a positive number for my discriminant, which means it's not 2 imaginary roots and it's not 1 real root. Okay? Now I'm between 2 rational or 2 irrational. 2 rational roots is if my number is positive but also a perfect square. And in this case, 52 is not a perfect square. So my types of roots, my number is 2, and my type is irrational. So 2 irrational roots. This is the value of my discriminant, 52. This is the number and type of roots it describes. It just means if I finished off the whole quadratic formula, the answers I'd get for x would not be rational numbers. They would have a radical still involved. Totally makes sense. If you've got a non-perfect square under the radical, a radical is still going to be involved. This stuff comes together, This is why we do this stuff. I think one of those is enough. And again, you have the rest of the answer key and you have the other stuff. Oh, hey, same equation. Well, I already know it in standard form, so let me write it in standard form because I know that that's what I need to do the rest of this stuff. So let's see. Oh, now I want the sum and product. And sum and product, again, has to come from standard form because it's got the A and the B and the C involved in the formulas. And the deal with this is the sum of the roots equation is -b over A from the formula. And the product of the roots equation is C over A from the formula. Well, we're kind of lucky here because A is 1. And dividing by 1 keeps our other numbers themselves. So really for the sum, you would just opposite sign here. So -2 is the sum of the roots. And for the product, correct sign from back here, -12 is the product of the roots. Let me just do that on number 11, just in case you don't have an A value of 1 and you want to make sure you have fractions, right? So this is in standard form. The sum of the roots is going to be sum, remember, -b over A. So this is going to be the negative of -3 over -2. So 3 over -2. So it's still negative, 3 halves. And then the product of the roots is C over A, which is 5 over negative 2, which is going to have to stay that way, so negative 5 halves. And that's it. That's where you get sum and product from. I left you room, but you really don't need it. You're just you're making sure you got standard form and using your A, your B, and your C. Now, this one's a little bit more complicated, and I'm going to leave the integer one and I'm going to do the fractional one for this. This one basically is saying, hey, look, I'm going to give you two roots. I need you to go backwards and tell me what equation those come from. Well, since we know the sum and product formulas, we can do that very easily. We just have to take the two roots and add them together and multiply them together. So multiplying a fraction and an integer is a lot easier. So that's the one I'm going to start with. I'll save room for my sum, of course, right here. But my product is going to be a heck of a lot easier, which of course is 1/3 times 2. And it just puts 2 over a 1 and multiply straight across. You get 2/3. Well, what that tells me is that my C value is 2 and that my A value is 3. So I've got 2 of the 3 letters I need to make standard form of my quadratic equation. Now I just need to get the sum. Well, the thing is, for the sum of a fraction and an integer, you need both things to be in fraction form with the same denominator. So I've just got to convert my negative 2 into having a denominator of 3. So they can have the same denominator. Well, let's see. Let's think. This is negative 2 over 1, really. So 1 times 3 gave me 3 down here. That means just multiply by 3 up here. I get negative 6. Now add your numerator. You get negative 5 over 3. Now notice your A value is the same, which is important. You need that A value to match up for plugging it back into the equation. And now your B value is the opposite of what you have here. So that means my B value is positive 5. So now plug those in, you get 3x squared plus 5x plus 2 equals 0. That's your quadratic equation it comes from in standard form. Let me do another one of those. I just did the fractional one. I'm saving you the integer. Why don't I think the radical is actually more challenging than the I in this case. Sum. Add them up. So you get 3 plus radical 7 plus 3 minus radical 7. Well, the thing about this is, think about it. The radicals are opposites of each other. They cancel out. No radical left. 3 plus 3 is 6. So you know right now that this is really a 6 over 1. So your B value is negative 6, the opposite sign. And your A value is currently 1. All right, let's see if that A value gets to stay a 1. And it will get affected if the product doesn't turn out to have a 1 in the denominator. So let's multiply these together. And the thing about these, when you have radical answers, is these guys are conjugates, which means this is the one type of radical stuff you can actually plug into your graphing calculator to figure out what it is. They're conjugates. They've got an opposite middle sign. So 3 plus radical, where's my radical? Oh, there it is, sorry. 7 times 3 minus radical 7, and then arrow out before you do your end parenthesis. And we get 2. So that tells me that 2 over 1 is my answer. The 2 is the C value, correct sign. And look, that A value matched up as a 1. So that's the number in front of your x squared. You don't have to write it in front of your x squared. You do have to make sure you have the correct sign of the B term. That's going to be key. Okay. Now, still using sum and product of the roots, and let me just reiterate them up here. Sum of the roots, remember, is negative B over A, and product of the roots is C over A in your standard form, AX squared plus BX plus C equals 0, okay? So that's just to reiterate what I've been using and I'm going to continue using right here. If I give you part of the equation and one of the two roots, you just have to do a little combo of things to figure out what the other root is and then figure out what the other letter is. Okay? So if I give you one root and the middle, well, you know that the sum of your two roots, so 4 plus my other root, is going to give me the opposite of what's in here as your b value, right? It's going to be the negative of b. Well, that's positive 2. So actually, all I have to do is subtract 4 from both sides. I get my other root to be negative 2. So 4 is one root, negative 2 is the other root. Well, product means multiply those. And I get negative 8. That means your end value, your C term, or your K in this case, is negative 8. Did it say I need to restate? No. Just said I needed to find the value of K. That's it. If it's the other way, if it's, oh, you're only finding C. Huh. I guess that's the one I'm going to use on the test, huh? That's the way you work it. Okay. This is the one that everyone is fearing. Truly don't know why, but I will do it right here so that you don't fear it. This is the end of the test where you are going to have to be given a system of equations, system of functions, I should say, and you're going to solve them algebraically and you're going to solve them graphically. Now, I personally find graphing to be easier or quicker, I guess I would say. So that's how I'm going to start. All right. I'm going to start by graphing this. And the first thing I notice is I've got a parabola and a circle. And how do I know that? Well, this is a frowny face parabola because there is one x squared present, and that is the highest present exponent. That x squared is negative. This is a circle because I've got an x squared plus a y squared equals a number. It's in the vertex form, well, center and radius form of a circle. So this is a circle where your center is 0, 0. And your radius is the square root of this number right here. The square root of 4 is 2. So I would start here and go out 2, and right 2, and down 2, and left 2. Should have said up 2 there, sorry. Did I still lose my, I did. Where the heck is my compass? I let one of you people borrow my compass and I didn't get it back. Why are you stealing compi from me? Just like to have pretty circles, you know? Just like to make them circular because, you know, circles can't be diamonds. So I like to use my compass so I get a pretty perfect circle. Hold on. My pencil is actually so tight in this that not going to work. There we go. Okay. I find it easier to move my paper than to move my compass. Personal preference, I suppose, although this paper is not moving. There's one side and another side. Oh my gosh, sloppy, 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 sloppy. Let's try it again. I'm gonna move this paper from underneath and maybe that'll help move my paper. Sloppy, sloppy, sloppy. Okay. It's not even touching. Let's try this again. Okay. Again. At this point, I'd be better off drawing myself a little diamond, right? There we go. You know, I wish I had my other compass. Whoa! I have ripped holes in this paper. I'm going to sketch. I've given up. I've given up on this terrible compass. I hope my other compass is somewhere so I can find it. Yikes. You stink. I feel bad. I think the pencil just needs to be sharpened. Probably shouldn't tell my compass that it stinks. It really doesn't. Probably the user. There we go. Okay. Much better. Now, I don't yet know where my parabola is going to go in comparison. So let's plug that guy into our graphing calculator and get a little XY table to graph that parabola. So y equals, I'll do this in blue. Ah. Let's see. Negative x squared minus 2. Let's see what that looks like. Press graph to see it. Oh, okay. So down there a little bit. Gonna be frowny face. Oh, no real roots here because it doesn't touch across the x-axis. It's below it and heading down. Wow, it looks like, hold on real quick. Let me enter the circle down here in red. Of course, red is like the last one. This side, I'm going to do the second square root of 4 minus x squared under here. And this one, I'm going to do negative square root of 4 minus x squared. I just got my circle in y alone form, which meant taking the square root of both sides. So a plus and a minus. That's each section. Ah, yeah, one intersection point. You know, there's 4 possible intersection points with a circle and a parabola on the same graph. But because of where your parabola is, this is the highest the parabola ever gets, which is the end intersection point of this circle. So that's it. That's the best you got. Second in graph gives me, remember, your circle is going to have all those errors because it's never going to be in those surrounding x values, never going to be used by those surrounding x values. Its domain and range is so limited. All right, so that's why all those errors, but you can see the values for the blue, which is your parabola. So we'll go from -3 to 3. I can fit -11 just above. And then that way we've got lots of room here. So -3, -11, or excuse me, just below, I guess I should have said, -6, -3, -2, and then back down. Again, no real roots to speak of, right? There's no y changing value because there's no crossing the x-axis. So this is my vertex right here. Point on each side, and then 1, 2, 3, point on each side, and 1, 2, 3, 4, 5, point on each side. And that's it. Arrows. Arrows. Now I can label. So y equals -x squared minus 2. And this is x squared plus y squared equals 4. And intersection point, red and blue make purple to much of your delights. It's trash color. This intersection point is 0, -2, and that's it. That's all I got for an intersection point. One intersection point, which means when I solve these algebraically, I'm only going to get one real answer. So that's actually kind of neat because it helps me to understand that when I go to do this algebra, right, when I go to get the y's equal to each other or sub that in for y, that's actually the best move, right? Take this and sub it in for y right here. Okay, so you've got x squared plus -x squared minus 2 squared equals 4. So now really what you've got here is -x squared minus 2 times -x squared minus 2, which means when you FOIL that, you get x to the 4th, and then a positive 2x squared, and then another positive 2x squared, and then lastly a plus 4 here. And we're going to combine like terms, x to the 4th plus 4x squared plus 4. Aha! Looking good so far. And then equals 4 over here. We'll bring down this guy from before. And now we'll add those up and we'll bring this 4 over. Yeah, let's get standard form. Why not? So subtract this 4 over. Oh, they cancel on both sides. These two combine to give me x to the 4th plus 5x squareds equals 0. Well, that's going to give me a GCF of x squared. And then it's going to leave me an x squared plus 5 equals 0. Oh, this makes sense. Because now if I set each of these equal to 0 in my t-chart, x squared equals 0, take the square root of both sides, you get x equals 0. And when you plug that back into this equation, you're matching y is -2. So 0, -2. That's your matching y. And that was the one intersection point. And the reason I say that makes sense is because if I try to solve this quadratic equation, I have to subtract 5 over here and then take the square root of both sides. I end up getting a negative number under the radical, which is imaginary, which is why that doesn't yield any rational response. So here, this is actually plus and minus I radical 5. And again, I'm not going to sub that back in and get a matching value for y, because what that's saying is the x values, the roots for that, are imaginary. They do not exist. So we're not going to have them on the graph, which we don't. That's why we got 1 instead of 3 or 4 potential intersection points. That's the reason, because we got an imaginary x there. So this is my one and only intersection point right there. Algebra, matching graph. That's how I checked myself. I knew looking at my graph I was going to get one answer, and I did. One intersection point. I got it. Okay. That's the tough one. That's the one that's going to be on the test, right? That's the match, a circle and a parabola, because that's what I really need to see, to be quite honest with you. So I won't even bother doing number 24 in front of you, but what I am going to do very quickly is each one of these, one by factoring, one by taking square roots, one by completing the square, one by quadratic formula, because there's one of these on the test as well. Okay, one of each of these. When you're solving by factoring, just get standard form and you factor in t-chart. So subtract that 6 over x minus 1 and x plus 6 will subtract to give me that positive 5 in the middle. And you do have to set each factor equal to 0, but there you go. You get x equals -6 and positive 1. By taking square roots, get x squared alone, and then take the square root of both sides. So add the 25 over. 9x squared equals 25. Divide both sides by 9. Do not worry about reducing that fraction because 25 and 9 are both perfect squares. So leave it like that. Take the square root of both sides. X equals plus and minus 5/3. And that's perfect. Leave that as your answer. Do not worry. Hello. Do not worry about turning it into a decimal or anything further than that. Okay. Over here, it'll be imaginary because you're subtracting 16 over, which means that when you go to take the square root of both sides, you get x equals plus and minus 4i. Now, last but certainly not least is completing the square. When you complete the square, you want your x squared and your x term alone, and then you can add to both sides. Oops, I tried to do it already. And 2 divided by 2 is 1. 1 squared is 1. That's how I know what to add to both sides. The whole point is to get a binomial squared and then take the square root of both sides. So x plus 1 equals plus and minus 4. So this is going to yield me actual integer answers. So negative 1 plus 4 is 3, and negative 1 minus 4 is negative 5. Quadratic formula is the last one. When you're using quadratic formula, use standard form. Your A is 1, B is negative 3, C is positive 2, and plug into x equals negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. And if my 3-year-old toddler can do it, so can you, right? So, zoom out so you can still see some of the completing the square. I get x equals the negative of negative 3 plus and minus the square root of negative 3 squared minus 4 times 1 times 2. I can just plug that part over 2 times 1. I can just plug that part into my graphing calculator if I so choose, right? So second and quit. And let's just do negative 3 squared minus 4 times 1 times 2. And I get 1. So that's what goes under my radical. X equals 3 plus and minus the square root of 1 divided by 2. Well, the square root of 1 is 1. So now what I've got is 2 of these, right? 3 plus 1 is 4. 4 divided by 2 is 2. 3 minus 1 is 2. 2 divided by 2, 2 divided by 2 is 1. So my answer here, 1 and 2. If they are integers, make sure you actually finish them because they are like terms. You have to actually add and subtract to get those answers. Answer keys posted. If you need anything, please let me know. Guys, practice. Your exam will be long, but you've got this. See you soon.